Yo, 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 this is Mr. O, and today we're going to learn about radian and degree measure. Okay, and basically, we're introducing to you what is trigonometry, which you should have somehow, somewhat have seen some of this one in geometry. As derived from the Greek language, the word trigonometry means measurement of triangles. Okay, it's very a big topic in mathematics, in applied math, wherein it's been used in many applications like sound waves, light rays, pendulums, and more. Even in the planetary orbits. Okay, so let's go ahead now and start dealing with trigonometry. The start of this one here, the approach that I do is that we will go with things that you know. We know what is x and y plane. This is the x-axis, this is the y-axis. And we learned that one as early as pre-algebra. And in geometry, we learned that this is the vertex, and this is the size of the angle. And these two sides form an angle. Imagine that this angle here, okay, goes to your x and y plane, or basically this vertex here will go to the origin. This is the origin, right? And goes there, move, 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 boom, it hits over there. Now you have your angle on a Cartesian plane. And what if at the same time this one here is gonna be, let's say, one of its side, this side here, let's say this is the initial side, starts or lies exactly on the positive x-axis. There you go. Now, what we have formed here is a standard position of an angle in trigonometry or in measuring an angle. So, the initial side of this angle lies on the positive x-axis, and this side here, this red one here, or that's not red, that's your terminal side. Terminal side. And this is the angle that's being formed. Most of the time, the angle is being represented by a this notation, or we call it theta. Okay. The measure of an angle is determined the amount of rotation from the initial side to the terminal side. So meaning, if you have your initial side here, that's your IS, initial side, and let's say this is your terminal side, TS, IS. The movement from the initial to terminal side determines or the measurement of an angle. So sometimes it creates like an obtuse, acute, or right triangle, or it could be a straight angle, or it could be more. Okay, so let's go ahead now and try to draw a angle in a standard position if you're given, let's say, 45 degrees. So again, your initial side will be on the positive of the x-axis. By now, at least you have an idea that this measures 90-degree angle, right? So the 45 should be half of that. So the 45 should be right here. That's your terminal side. This is your initial side. And the 45 degrees should lie over here. That is the 45 degrees. Okay. Now, if you have 270, so let's go back again here. So this is my initial side, IS. If it falls here, it's going to be 90, right? That's 90 there. If it goes, if this is my initial side, and my term, this is my vertex, and my terminal side goes here, that's a complete straight line or a straight angle, 108 degrees. And if this is my initial side and it goes down here, it rotates counterclockwise, more than 180. This goes on the below the y-axis, that is 207 degrees. If you notice, all movement of the angles here are moving CCW. What CCW stands for? Counterclockwise. If it goes counterclockwise, the angle is getting positive. So means say if it's the other way around, if it's clockwise, the angle becomes negative. Let's look at this example here. Let's draw a negative 60 degrees in a standard position. So we start at the initial side. We know if it goes clockwise, it becomes negative. So if it stopped here, clockwise like that, this becomes negative 9 degrees. But negative 90 is a little too much on negative 60, so that's not the right graph. So it should be somewhere, has to be right here. So I can erase this part. And this is the measurement of negative 60 degrees, okay? I want you to copy and try this one here and try the three example here. So example number one, two, and three. For four, five, and six, I want you to draw 100 degrees, negative 300 degrees, and negative 180 degrees. Okay, try to draw this angle in a standard position. All right, so in trigonometry, there are two ways to measure angle. They're called the radian and degree measure. Most of us are very familiar with degree because we have seen this one in many places and also in our course subject prior to this class, like geometry. So let's start first with radian. What is radian? One radian is the measure of a central angle that intercept an arc S equal in length to the radius of the circle. This is the explanation I can give you with that. Let's say this is my circle in my Cartesian plane. So this is my vertex or origin. This is my radius. And we know, let's say this is also a radius there. They're equal measurement. Okay? If they're equal measurement, it intercepted an arc, this brown one here. And let's say if we measure that crust of the pizza, okay, we can say that crust of the pizza is the same measurement as your radius. That's also R. And we call that one as your S. That's the arc being formed by the that's the intercepted arc. Okay? Is the intercepted arc. That measures the same much as your radius. And the angle is this theta here. That's the angle. Okay? With that, a 1 radian is the measure of the central angle that intercept an arc. So meaning say the theta is S over R. Okay. So the intercepted arc divided by the radius will give you the theta. Where theta is the measured in terms of radian. Okay. So meaning to say, that space there. Okay, there you go. If this one here is 1 radian, this is 1 radian here. Imagine this is your arc, intercepted arc, right? Another radian will be somewhere right here. That's another radian 2, radian 1. Another radian there will be somewhere right like here. Oh, it's not really perfect. Hold on, let me do it again. That's radian, radian, radian. Another radian there will be kind of a little off than this one here. The other one will be over that. And the other radian will be somewhere right here. Okay. So these are radian, radian there, radian, radian. If you notice, we have radian 1, 2, 3, 4, 5, 6, and a little more portion right there. So there are around more than 6 radian in a full circle. Do you know why? Because the circumference of a circle is 2 pi r. If the radius is equal to 1, therefore this will be 2 pi, and we know a pi is approximately 3.14. So if you multiply 3.14 by 2, it gives you a 6.28 radian. That's why this is the 0.28 value of the circumference of a circle. That's the a little background and explanation to that one. And we will discuss more about radian in the coming topics. Okay. Now, so again, one radian is basically like one slice of pizza, another radian there, another radian, and so on and so forth there. Okay, those are the basic. You can think about it that the radian here is right here. Okay, that is the measurement. Okay, of the two intercepted arc. Now with degree measure, with the degree measure, it's more like uh it's easier for student to understand this one because again we always start with our initial site right here is 0 degree. If it goes counterclockwise, it's going to be positive, right? If it goes this much is 30 degrees, 60 degrees, 90 degrees, 120. We all know when you turn your back, it's a full 108 degrees. If you do one complete revolution, when like those people who do dunk, they call it 360 because you turn and then you turn again one more time, it's 108 degrees, right? um and we just have to be familiar with this one here. Okay, if you notice, everything between 0 to 90 falls on the first quadrant, everything from 90 to 180 goes on the second quadrant, and 180 to 270 goes to the third quadrant, and last one 270 to 360 falls on your fourth quadrant. Okay. Now, um, another thing that we have to learn here is that since we know that the two way to measures are degrees and radian, they are equal, but it's just a different representation. So we're gonna learn today how to convert degrees to radian. Okay, so to convert degrees to radians, here's the formula. Just multiply degrees by pi over 180 rad because you're converting the degrees to radian. And vice versa, to convert radians to degrees, multiply radians by, guess what? Guess what, guys? It's going to be the reverse. It's going to be 180 over pi rad on the bottom degrees. So the answer will be in terms of degrees. Okay. So let's practice that one. Okay. So let's say let's say convert 135 degrees to radians. How do we write this down there? Okay. So again, if you want to convert this to radian, so the 135 degrees will be multiplied. So let's look at our cheat sheet here. We're gonna convert radians to degrees and degrees to radians. So we will multiply this by pi over 180 rad on top. Okay, we can use our calculator here. So we'll keep our answer here in a fraction form because it's pattern and keep it uniform with our unit circle. So this will be 135 pi over 180 rad. And if you will notice 135, you can divide 135 by 180. That gives you 0.75, or hit the math frac of your calculator will give you 3 pi over 4 rad. So that's the radian form of the 135 degrees. Vice versa, if you're given, let's say, 9 pi over 4, you're being asked to convert this one into degrees. What do we need to do? We have to multiply the 9 pi over 4 by 180 over pi rad on the bottom. Okay, so this will cancel those pi there. So 9 times 180, divide by 4, 405
Good
degrees.
afternoon, warriors. Please.
200 degrees into radian. Convert pi over 6 to degrees. Okay? There you go. I hope you learned something as always. Kaboom.